Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023 paper 2 variant 1. In the last video, we have discussed first half of this paper, and in this video, we will try to cover the remaining half of this paper. Means we will talk about waves, we will talk about electricity, we will talk about radioactivity. Let's study together, let's improve together. Question 4 says, a beaker in air contains a liquid. The base of the beaker is in contact with the liquid and has area capital A as shown in figure 4.1. The liquid has density ρ and fills the beaker to a depth h. By using the definitions of pressure and density, show that P is equal to ρgh. P is the pressure due to the liquid that is exerted on the base of the beaker, and G is the acceleration of free fall. So in order to answer this question, a pretty straightforward question for AS student, the best way to answer this question is we can start with the P is the pressure, and P is equal to force over contact area, F over A. And force in this case means force on this area. This force is due to the weight of the liquid. So simply we can say this is equal to weight of the liquid, W divided by A. And W is equal to M times G. So this is M times G divided by A. And M is equal to density of the liquid times volume of the liquid. And volume of the liquid simply we can express in terms of A and H. Means the cross-sectional area of this beaker, if we multiply with height, that is equal to the volume of this beaker. So this is the volume times G, and this is divided by A. So simply you can cancel A with A. So we left with rho GH. So this is what we need to prove for this question. Part B says, suggest why the equation in A does not give the total pressure on the base of the beaker. We have already calculated that P is equal to rho GH. But this is not equal to the total pressure on the base of the beaker. So we have to explain why it's not. So we can simply write down here. So this is P total. P total has to be equal to rho GH plus something is missing. And that one is the air, because on the top of this beaker there are air particles, means there is atmosphere. So you can simply imagine there is atmosphere on the top of that atmosphere, and atmosphere is exerting also pressure at the surface. So the total pressure at the base of the beaker, this is equal to rho GH, means due to liquid. So this is the pressure due to liquid. So we can say this is P liquid plus P air, or you can say P atmosphere. So this is how you can calculate P total. So simply we can say, because there is air pressure, or you can say there is atmospheric pressure. You can say air, or you can say there is atmospheric pressure. So this is how you can answer. This question has only 1 mark, and that one has to be the B mark. Part C says, figure 4.2 shows the variation of the total pressure inside the liquid with depth x below the surface. Determine the density of the liquid. So in this case we have pressure on y-axis and we have depth on x-axis. So simply if you look at the gradient of this one, gradient of the graph, gradient will be equal to delta P over delta H, delta P over delta H. And now if we compare delta P, we can write down change in pressure. This will be equal to rho G delta H. From here we can write down delta P over delta H. This one will be equal to rho times G. So simply in this case we can say rho, this one will be equal to delta P over delta H, and this will be divided by G. So we have G here. So simply we can say we need to calculate the gradient and we need to divide gradient by G. So in order to calculate gradient, we can take one point here, we can take one point here, you can take any 2 points. but it's better to take these 2 points because it is more convenient to calculate. So here we have value of P, that is equal to 9.66, and we have value of P here, that is equal to 9.60, and this is multiplied by 10 to 4, and this is divided by delta H, means from here to here, and this is in centimeters, so we have to be careful with units. So this is 8 minus 0 multiplied by 10 to minus 2 multiplied by value of G, that is equal to 9.81. Now if we just simplify, we will get our answer, that is equal to 764.5 kgs per cubic meter. Up to 3SF we can write down this is equal to 765 kgs per cubic meter. So this is the final answer, and this is how you can calculate. So it simply means that in this case rho is equal to gradient divided by G. So when you have any question about the graph, so first of all look at the gradient of the graph, and second look at the area under the line, so you can get informations to calculate any quantity they ask you to calculate in the question. In this case we have to consider the gradient, then rho is equal to gradient divided by G. So this is part D says a solid cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid as shown in figure 4.3. The cylinder has length 4.0 times 10 to minus 2 meters and cross-sectional area of the cylinder is 3.7 times 10 to minus 4 meters square. The tension in the wire is 0.53. The cylinder is now lowered and then held stationary by the wire so that the top of the cylinder is level with the surface of the liquid. Calculate the new tension in the wire. So we have two cases. First of all, we can say case 1. For case 1, if we draw the free body diagram, we have mg of the cylinder that is acting vertically down, and we have in this case tension that is acting vertically up. This is the tension in the wire, and this is equal to 0.53 newtons. So from here simply we can say mg is equal to T because the cylinder is not accelerating. So it is stationary, it means forces on the cylinder are balanced. Or simply we can say the weight of the cylinder, this is equal to 0.53 newtons. So this piece of information we can get from case 1. And for the second case we can use a different color. For the second case, it is given to us that top of the cylinder is level with the surface of the liquid. So until here, now we have liquid. So we can draw this line. Until here, we have liquid. So this is the second case, the red one. So we can say this is our second case. For the second case, if we draw the free body diagram, we can draw mg will not change. So mg is still acting vertically downwards, and there is a tension in the cylinder. So we can draw there is some tension in the cylinder. So this one is the tension. So we can say this is T, and also there will be upthrust on this cylinder due to the liquid. So this one is the upthrust. And in the second case, cylinder is still stationary. So it simply means that in this case mg is equal to T plus U, but we need to calculate the new value of T. So this is T new. So we can also write down here T new. So we have to calculate T new. So we can write down here T new. This one will be equal to mg, and this will be equal to mg minus upthrust, and mg is equal to 0.53 newtons minus the upthrust. And upthrust is equal to weight of the fluid displaced. Weight of fluid displaced. So we can say weight of fluid displaced. I'm just writing in detail so you can understand this one, not just simply use direct formula and give you the answer. I want you to feel, I want you to understand. Okay. So now here we have this is 0.53 and weight of the fluid. So it means this is equal to mass of the fluid. So let me write down here weight of the fluid. This will be equal to mass of the fluid times G. And mass of the fluid will be equal to density of the fluid times volume of the fluid displaced times G. And for this cylinder, we have cross-sectional area of the cylinder and we have its height. So we can say this will be equal to rho F times, because this is the volume of the fluid displaced, equal to the volume of the cylinder. So this is, so we can write down this is A times L times G. Now simply we need to plug in numbers. So we have here, this is rho F times A, cross sectional area of cylinder, times height of the cylinder, times value of G. Now simply we need to plug in numbers. So we can write down T nu, this is equal to 0.53 minus, we have density we have already calculated in the previous part, that was equal to 764.5, and value of A is given to us here, and this is 3.7. so this is 3.7 times 10 to minus 4, and we have value of L that is given here, and this is equal to 4.0 times 10 to minus 2, and we have value of G that is equal to 9.81. If we solve this one, our answer will be about equal to 0.42 Newton. So this is new value of tension, and this is how you can calculate. Question 5, part A says an electromagnetic wave in a vacuum has a wavelength of 8.4 times 10 to minus 6 meters. State the name of the principal region of the electromagnetic spectrum for the wave. So this is 10 to minus 6, and if you look at the spectrum, 10 to minus 3 to 10 to minus 6 meters wavelength, this is in infrared range. So this is infrared. So this is this range you need to understand. So this one is infrared. And for the second part, we need to calculate the frequency, and our answer has to be in terahertz of the wave. So we have the wavelength and we need to calculate frequency. Frequency simply will be equal to V divided by lambda, and speed of light means speed of electromagnetic waves in vacuum is equal to 3 times 10 to 8 meters per second, and the lambda is given to us, that is equal to 8.4 times 10 to minus 6. And now if we solve this one, we will get 3.6 times 10 to 13 hertz. So this is the frequency, but answer has to be in terahertz. So we can write down 3.6 and times 10 to 1 tera, 1 tera, this is equal to 10 to 12. So this number is important. So this is 10 to 12. So it means that we have 3.6 times 10 to 1 tera. Simply we can say this is equal to 36 terahertz. So the final answer is 36. Part B says an arrangement that uses a double slit to demonstrate the interference of light from laser is shown in figure 5.1. The light from the laser has a wavelength of 6.2 times 10 to minus 7 meters and is incident normally on the slits. The separation of the two slits is A. The slits and the screen are parallel and separated by a distance of 2.8 meters. 2.8 meters. An interference pattern of bright fringes and dark fringes is formed on the screen. The distance on the screen across 8 bright fringes is 22 millimeters as illustrated in figure 5.2. For part B1, the light waves emerging from the two slits are coherent. State what is meant by coherent. Coherent simply means that the phase difference between two waves remains constant, or simply we can say two waves, they have the constant phase difference with time. So simply we can write down constant phase difference between the waves with time. Means the phase difference between waves does not change with time. If the phase difference between two waves, let's say, is 90 degrees, it remains 90 degrees with time. It does not change with time. If the phase difference is 180 degrees, it remains 180 degrees with time. For the second part, we need to calculate the separation A of the slits, and this experiment is about double slit. So simply we can say in this case A times X, this one has to be equal to lambda times capital D. A we need to calculate, so A will be equal to lambda capital D divided by X, and X is the fringe separation. So this is fringe separation. Very important concept. You need to understand what exactly it's meant by fringe separation. Fringe separation means that distance between two consecutive bright fringes. Distance between two consecutive bright fringes. Bright fringes. Very important point to understand. Bright fringes. If this concept is not clear to you, you can't do this question. For this one, you can see we have, this is representing the bright fringe. So we have one bright fringe here and we have another bright fringe here. So it means this distance, this is value of x, and here you can see we have another, so this is also value of x, and this is also value of x, 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 and this is also value of x, and finally this is also value of x. Now if we count this one, how many we have? 1 2 3 4 5 6 7 8. So it simply means that we have 8x, that is equal to 22, and we need to find out value of x. So this is 22 divided by 8, and this is in millimeters. Now simply we need to plug in values here. Value of lambda you can get from here. It is given to you, that is equal to 6.2 times 10 to minus 7 meters, and value of d is given, that is equal to 2.8 meters divided by x. X is in millimeters, so this is 22 by 8 in millimeters, so we have to convert this one into meters. Now if we simply solve this one, our final answer will be equal to 6.3 times 10 to minus 4 meters. So this is our final answer. Part C says fringe P is the central bright fringe of the interference pattern in P. Fringe Q and fringe R are the nearest dark fringe and the nearest bright fringe respectively to the right of fringe P as shown in figure 5.2 respectively. So it means fringe, dark fringe is Q and R is the bright fringe. We need to calculate the difference in distance, or simply we need to calculate the path difference from each slit to the center of fringe Q. So here we have bright fringe here, next one is the dark fringe, then we have the bright fringe. So we need to understand n for the center bright fringe is equal to 0. So this is the fringe order, and n is equal to 1 for the first bright fringe after center bright fringe, n is equal to 1, and for the next bright fringe n is equal to 2. So we need to understand the meaning of that. N0 means that PD is equal to 0. N is equal to 1 means that PD, the path difference, this one is equal to 1 lambda. N is equal to, it means the PD for this bright fringe to be formed has to be equal to 2 lambda. As the dark fringe is between n is equal to 1, n is equal to 0, so the PD for the dark fringe, so we can say PD for dark fringe, this one has to be equal to lambda by 2. We can also write down the journal formula. For bright fringe, we can write down a journal formula for bright fringe. Bright fringe, we can say PD has to be equal to n times lambda. N can be 0, it can be 1, it can be 2, it can be 3, and so on. And for dark fringes, the PD, this can be n plus 1 by 2 times lambda. So when n is equal to 0, so we can say n is equal to 0, so the PD, this one has to be equal to lambda by 2. So lambda by 2. So for the first dark fringe, PD has to be equal to lambda by 2. We can also understand this one wave is coming here, another wave is coming from this slit. So what is the PD between these two waves? PD, this PD has to be equal to lambda by 2. If we draw the normal from here, so the PD between these two waves, so this is PD, and this PD has to be equal to lambda by 2. And so this is the concept you need to understand. So simply we can say PD. We are talking about the dark fringe. First dark fringe, this one has to be equal to lambda by 2. And value of lambda we have, this is given in the question, that is equal to 6.2 times 10 to minus 7, and this is divided by 2. So our final answer will be equal to 3.1 times 10 to minus 7 meters. So this is the PD for the first dark fringe to be formed here. For the second part, we need to state the phase difference between the light waves meeting at the center of fringe capital R. And fringe capital R, we need to understand this fringe is a bright fringe. So this is bright fringe. So this is first bright fringe after center maximum. So we have here, and the fringe order for this one, n is equal to 1. If fringe order is 1, it means the PD, this one has to be equal to 1 lambda, and the phase difference, this one has to be equal to 360 degrees. So the phase difference simply between the waves has to be equal to 360 degrees. So these waves are still in phase.